Hello, everyone. Welcome to another episode of Flash Forward Fridays, where you can hear about STEM in the professional world. I'm your host, Avika Arunkumar, Operations Coordinator for the Londonderry High School Robotics team. With me today is one of our very own mentors, Brendan McLeod. Brendan is an LHS alum and was on the robotics team throughout high school. He then went to Worcester Polytechnic Institute, graduating in 2015 with a dual major in robotics engineering and mechanical engineering. Brendan then worked at an early stage startup for 5 years before going on to become a hardware development engineer at Amazon Physical Stores. Welcome, Brendan.
Hello, Diga.
So at a high level, what does your position entail at Amazon?
Yeah, so I'm hardware development engineer for Amazon Physical Stores. And so that means that as Amazon is looking to expand our presence in the retail world, we're doing things like bringing some of these technologies that you would normally see hidden in a factory floor somewhere, and bringing them to the real world. So you can see this in some stores like the Amazon Fresh stores. Some of you may have heard as Amazon Go. I particularly work on a product that was recently announced called the Amazon Dash Cart, where we help bring automation and retail ease to customers. So I'm a mechanical engineer. I help develop technologies such as computer vision systems. I develop touch displays for user interfaces. I develop neat ways of either automating build processes, or how do you design a structural system that someone's going to handle every day. So being an engineer means more than just waking up, doing your job, and leaving. And so as an engineer, your position is a little bit more than as it's dictated to you. So while I may be asked to design a handlebar for a smart shopping cart, that might end up with needing to create new ways to simulate impact forces of a shopping cart rolling down a street.
Mm-hmm.
So my position is primarily based in mechanics. I do a lot of computer-aided design. Most of my time is spent doing computer-aided design, but that also means testing systems, getting your hands dirty in electronics, and maybe writing a few lines of code for some test systems that you might be working on.
That sounds really interesting. And I'm sure a lot of students in FIRST already are starting to develop a lot of those skills that you use in your career every day. So speaking of FIRST, how did being part of 1058 and FRC influence your career path? Did that provide you with any additional opportunities? And what skills from your STEM or robotics experience did you use in the professional world?
I'll start with the last one first. What skills did I use in the professional world? Because it's all of them. A lot of people say it. They don't necessarily mean it when they say it, but I really mean it. I don't think there's a single thing that I learned as a student on a FIRST robotics team that I don't use at least once per week. Maybe it's not every day, but even the silly things like how to make a cool logo for the team. You're writing a document that you have to present to your managers or their managers or a new customer, and it has to look good. We're engineers. We thrive off of data, but you have to be able to communicate with that. Everybody's going to talk about how they learned about screwdrivers and design and mechanics. And of course, as an engineer, you're going to use that. But what people don't realize is that it's all those other skills you learn in robotics as well. It's your communication skills. It's your how to work well under pressure. It's when you're the driver and you have 2 minutes for that match, you have to make decisions right on the spot that is going to change what it means for your entire team. If you choose to drive the robot the wrong way, your whole team is depending on you. And it's the ability to think on your feet like that I found the most valuable. My high school classes, my college classes, they taught me mechanics. I could learn thermodynamics. I could learn static and dynamic simulations. But no class is going to teach you what it means to be having a brainstorming session with your colleagues and how to take this vague concept in your head and get it onto a whiteboard in 5 minutes and present it to your peers in a way that they're going to say, hey, yeah, that is a good idea, or no, that's a really bad idea. Um, and I certainly got a lot of opportunities granted to me as a result of being a student on the team. My very first internship was actually with First Robotics, with their headquarters in Manchester. Um, through the grapevine, I just heard, hey, First Headquarters is looking for an intern this summer, and I did enough digging on my 10-person LinkedIn at the time and said, hey, how do I actually get this job? And I found a contact. I reached out to them. I sent a resume and got my first internship. Um, then I spent a couple months working at iRobot. That was certainly as a result of my hands-on skill during my time on a first team. Um, and everything kind of spirals from there. My senior project, the Walrus rover, the only reason I was able to pull off a project like that is I had that hands-on experience already. I didn't have to learn how to use machines when I'm a senior in college, because I learned that when I was a senior in high school. And it's, for me, it was really about taking all of these tangentially related skills and putting them together. We will I talk a lot with the high school students about systems engineering. It's not just being a mechanical engineer or electrical engineer or a computer scientist. It's finding a way to bring that all together. It's bring the technical with the non-technical, with the people who just want to draw cool things all day, and finding a way to integrate all of that into a professional development. A team is made up of a lot of people, and on a First Robotics team, you get to meet all of those people.
That sounds awesome. That like First has helped you all the way from high school and up until today in your career. So any last words of encouragement for aspiring engineers that are going to be watching this?
Yeah, keep going. Don't stop. Um, it's hard. There were certainly those 3 a.m. times in college when I said I would love to just go to sleep right now, and I'm not encouraging bad sleeping behaviors, but um, it gets challenging. There's going to be times where you have friends who are off at a party or just kind of chilling, and you say, well, I got to, finish my thermodynamics homework, and no one really likes thermodynamics, so no one's really thrilled about it. But it pays off a lot quicker than you think, and I mean that literally and figuratively. Um, your career growth is going to be exponentially higher than a lot of your peers. Your happiness. I mean, I can't properly explain to the high school students I work with how much it means to me to be able to have a career that is my hobby, that I learned about in high school, that I get to share with all of my friends and these students and my family. Um, you know, we say it all the time, but not everybody can go pro in football, but everyone can go pro in engineering. Um, and that has such a deeper meaning than just playing football or building robots. It's, when I wake up in the morning and I think, oh, I don't really want to go to work, I think to myself, what am I talking about? I'm doing cool things. I'm designing, neat things that fit together and that work together. And tomorrow I'm going to go run a big CNC machine so that I can test out that thing that I designed. Um, and people pay money to do that as a hobby, and now as an engineer I'm getting paid to do that. Like I'm getting paid to do things that people think are just like, oh, I would love to take part in that, and like it's my career. Like how cool is that? So it doesn't, you don't have to be in your late 60s for being an engineer to pay off. I'm in my mid 20s, and it's already you know the best decision I ever made to become an engineer. So like when you're sitting there thinking, wow, this really sucks and I don't want to be doing this right now, I promise you it gets better. You're going to love it. You just have to get through those hard times, and you will enjoy it later.
Well, thank you so much for your words of encouragement to any aspiring engineers that are going to be watching this. And thank you for your time today and your enthusiasm about STEM and your career.
Great. Thank you, Advika.
We'll see you next time for our next Flash Forward Friday. Everyone, thank you and have a great rest of your day.